Alright, so now that we understand how to work with vectors, adding vectors together so that they are linear, we can then compare different vectors and see how we can solve for a particular unknown using vector properties. So in example number 5, we are given vector A, y times vector B, and somehow they give us an equation to show us the relationship between A and B together. And what they want us to do is to find the values for x and y. So looking at the equation, 2a plus b, what it means is we are to multiply this vector by 2 times a, and then we are going to work with vector b, not using the y. So basically, if y is a constant, you just divide it to the other side. You will then end up with 3i plus j plus 2k. So 2 times a will give us 4i plus 2xj plus 2k. And then if you are to add it by vector b, what I'm going to do is to divide the y to the other side of the equation. So in this case, with vector b equals 1 over yi plus 5 over yj, then 2a plus b, when you are to add this and that together, will give us 3i plus j plus 2k. 4i plus 2xj plus 2k. When you add this by 1 over yi plus 5 over yj, will give us 3i plus j plus 2k. So these are ij and k are all unit vectors. Now, similar to complex number, knowing how well back in complex number, when you are given two complex number, you're going to match the real component with the real one and the imaginary with the imaginary. When you are dealing with vector, we can use similar concept. The I components together should match with the I component on the other side. Which makes sense because when you take a look at this equation, this is the only k component, and it matches with the other one, with the one on the other side. And using the same concept, the one that goes with the j component together will give us this term here. So as you combine these terms together, we'll be able to come up with a couple equations and we can solve from there. Looking at the I component, we have 4i plus 1 over y I equals to 3i. So looking at just the I component, the coefficient for the I component should match. So with 4 plus 1 over y equals 3, we can then solve for y. So in this case, we have y equals -1. And then for the j component, we got 2x plus 5 over y equals 1. That's the coefficient for the j component. And now knowing how we have y equals -1, we have 2x minus 5 equals 1, and therefore we have x equals 3. So in this case, these are the answers, these are the values for x and y.